Alright, so let's look at the fourth type of reaction. It's called a double replacement reaction. And these are always look very ominous. They look very intimidating because they generally have not generally, always have only ternary compounds. So they can be, or they usually have a lot of ternary compounds. So they can be kind of intimidating. Basically, it's similar to the single replacement reaction, but as you can see, it's called double replacement, which obviously means that two elements are going to switch with each other. Also, we'll introduce you to a term that's called a precipitate. A precipitate is a solid that's formed as a result of a chemical reaction that doesn't dissolve in water. In other words, it is insoluble. Now, how do you determine if it's insoluble? Well, you're going to have to use table F to figure that out. Here's table F. Yeah, it is pretty confusing. We will go over table F in the section on solutions, which is a later unit. But quickly, just to run through this, I'm not going to really worry about this for this unit. It'll really be for the unit on solutions. But just to quickly run through, what this chart is saying, it's broken up into two pieces. All of these substances here always dissolve in water, with some exceptions. So, for example, all of the halogens are soluble in water unless the halogen is combined with one of three elements: silver, lead plus 2, or mercury. So if you have a halogen with one of these three elements, it is not soluble. Otherwise, it is. If you have something with a sulfate in it, a ternary compound with sulfate, it is always soluble unless the sulfate is combined with Ag, Ca, Sr, Ba, or lead plus 2. Now the other part, it's the opposite table. These do not dissolve in water, which would mean that the exceptions do dissolve in water. So carbonates, anything with a carbonate in it, does not dissolve in water unless it has a group 1 element or ammonium. And you can see the rest of these here. So let's go back here. So it says see table F to see if they are soluble. So if you look at this, let's look at copper nitrate. It says nitrates are soluble and there are no exceptions. So anytime a compound has nitrate in it, it is going to be soluble. So it will form an aqueous solution. It is not a precipitate. What about lead chloride? Well, let's see. Chlorides always are soluble unless they combine with lead plus 2. So lead plus 2 will be a precipitate. So it's the way you indicate that is putting S. And you'll see the equation. And I'm going to go through this quickly. That would also be a precipitate, but that would dissolve. Here's the general equation. Let's do a very quick video demonstration. For some reason, this is not working now.
We're going to do a double replacement reaction with potassium chromate and silver nitrate. Here's my potassium chromate, and I see that when I add silver nitrate to it, I am forming a nice red precipitate. And the precipitate
That's the precipitate.
is silver chromate.
It's a solid, so that's why it's a
replacement
precipitate.
reaction.
Okay, so that's a good example of a double replacement reaction. So here's another example right here. And if you look at it, what basically happens in a double replacement reaction, this is a very common double replacement reaction where you take silver nitrate, which is this right here, react it with sodium chloride. What will happen is the silver and the Na will switch partners. The Na will join with the NO3. The silver will join with the Cl. Now, how do we get these formulas? Well, silver is a +1, chlorine's a -1, sodium's a +1, and nitrate's a -1, so they're all good that way. Also, if you check table F, you will notice that silver chloride, remember, halogens are soluble, but one of the exceptions is when it's combined with this silver. So this would be a precipitate. It is an insoluble product. This, however, does dissolve, so that would not be the solid. Okay, so let's run through and take, here's an example of a double replacement reaction. Now, even though they look ominous, they're not. So what it's saying, these are blank to let you know if you have to look to see if they're soluble or not. I'm not going to bother doing that right now, but here's barium, chlorine, what am I doing? 1 barium, 2 chlorines, 2 hydrogens. Notice the SO4, they didn't separate, as I had said before. Do the SO4 as one particle. It's a lot easier. I have 1 SO4. On the other side, again, I have 1 barium, I have 1 chlorine, I have 1 hydrogen, and I also have 1 SO4. So let's see. It's just the chlorines and the hydrogens that are not balanced. So I'm going to put a 2 here. That'll give me 2 H's and 2 Cl's. That balances it for me. So if you look at it, oops, I'm sorry. And these are 2 more. I'm not going to bother going through these just to save a little bit of time. As well as I'm sure there are probably word equations, which I'm not going to bother with. That reaction doesn't occur. And here are the answers. Okay, so it's just some more. These are word equations, but I'm not going to do these because it's just going to take a little